divisibility when we're doing the GMAT, and these divisibility tests come in handy. If a number is divisible by 2, well, how do you know if it's divisible by 2? Well, it's even. How do you know if a number is divisible by 3? Well, you sum the digits, and if the sum of the digits is divisible by 3, then the number is divisible by 3. How do you know a number is divisible by 4? Well, if the last 2 digits are divisible by 4, then it is divisible by 4. How do you know if a number is divisible by 5? Well, if the last digit is 5 or 0, it's divisible by 5. How do you know if it's divisible by 6? Well, we don't really want to think about divisibility by 6. We want to think about the prime factors of 6, 2 and 3, 2 times 3, and we've already checked for divisibility by 2 and 3 by the time we've gotten to 6, so we should know, by the time we're checking for divisibility by 6, we should know whether it's divisible by 6 because we know whether it's divisible by 2 and by 3. Divisibility by 7, well, there's no quick test. There is an algorithm called the SMART algorithm, which is included in your course materials, and some people find that a useful process to go through to learn that. I believe it's a bit time-consuming for our online course, so I'm not going to teach it. We will look at one way of checking for divisibility by 7 is simply to divide. Another way is to do what I call chunking, and we'll look at what chunking is and how it works in a minute. Divisibility by 8, well, it doesn't come up very often, but you need to think of 8 as 2 cubed. It's 2 times 2 times 2, and really what are you doing? You're dividing by 2, and then you could apply the check for 4 at that point. Divisibility by 9, well, sum the digits. If the sum of the digits is divisible by 9, then the number is divisible by 9. 10 is trivial. If the last digit is 0, then it's divisible by 10. There's no quick test for 11 any more than there is for 7. In the book, you have a couple of tests that you can apply, both of which I find to be a little bit long-winded, but we could just divide or chunk. If we're checking for divisibility by 12, well, we check for 3, and we check for 4, 2 squared. It's worth thinking about why it wouldn't work to check for 2 and for 6. If you thought about the number 42, well, 42 is divisible by 2, and it's also divisible by 6, but it's certainly not divisible by 12. That's because 2 and 6 are, in a sense, double counting. The 2 is 6 is just 2 times 3, so if you're checking for 6, well, you're checking for 2 times 3. If you check for 2 again separately, well, it's a meaningless test. Whereas if you check for 3 and 4, you're, in a sense, checking for 3 and 2 squared. Okay, now let's look at an example of chunking. This to me isn't, if we need to check for divisibility by 7, one way is to do our old friend long division, which we learned in school. I don't really like long division as a method of doing division on a test like the GMAT because I find that it's quite it's not very intuitive. You're looking at you're going through a mechanistic process, and I believe it's a mechanistic process that lends itself to a lot of mistakes. So let's try chunking for dividing 1065 by 7. The essence of chunking is saying, well, what's a number we can immediately think of, which is definitely divisible by 7? Well, 700 is obviously divisible by 7, and we can say, well, that's 100 times 7, and then we subtract 700 from 1065, and we check 365 for divisibility by 7. What's a number we can immediately think of that's less than 365 but is definitely divisible by 7? Well, what about 280? 280 is 40 times 7, leaving you with 85. Well, now we're down into the realms of the part of the times table that we certainly should have memorized. Anything up to 15 times 15, we really need to be able to do in our heads like lightning. And so we see 85, well, we immediately should think of 84, 12 times 7, leaving us with 1. So 1065 is not evenly divisible by 7. And in fact, if we want an answer, we can just add up the 100, the 40, and the 12 and say, yeah, 1065 divided by 7 is 152, remainder 1. This is quicker than long division in my view, and less prone to mistakes. Okay, now let's think about